All right, this is our last section. It's going to be a review of all of the volume formulas that we've talked about, well, area and volume. So good problem for review. So they've already got everything sketched for us here. You'll notice that they have the parabola and the line both written with y equals and x equals equations, so that when they change things up on us, we have both if we need to do right minus left or top minus bottom. So here we go. Part A wants us to find the area of R. So to find area, it's top curve minus bottom curve. In this case, it would be the line minus the parabola. So it's going to be the integral from, and they intersect at -1 and +2. So from -1 to +2 of top curve, which is our line there, and our line is 3x plus 3 minus our curve, x plus 1 squared. And I'm just going to do setups, and then we'll go back and we'll plug these into the calculator. Well, actually, let me just go ahead and get all of our solutions, and I'll just tell you. So this one, once you type it in, it's going to be 4.5. All right, next it wants us to find the volume rotated about the x-axis. And so we're going to have a space. We're going to have a space in here. And so here's what I'm looking at. If we're going around the x-axis, we're going to have this radius minus this radius. So our volume is going to be pi, and this is a disk one, times the integral from -1 to 2 of our outer radius, which is the line minus 0, or 3x plus 3 minus 0 squared, minus our curve minus 0, or our parabola minus 0 squared. All right, and so that one ends up being 101.788. For part C, it wants us to do the volume rotated about the line y equals 9. Well, y equals 9 is going to be up here. I think this is 9 right in here. And so again, we're going to have two separate radiuses, but this time top curve minus the bigger radius. The outer radius is going to be 9 minus the curve. So this time, still disk, we're going to have 9 minus x plus 1 squared, minus, and then we're going to take away the smaller one, which is going to be 9 minus the line for that radius. Oh, sorry, you can see I was right. 9 minus the curve squared, 9 minus the line squared. And we get that one typed in. We should get 152.681. All right, part D wants us to find the volume rotated about the line y equals -3. So -3 is going to be down here, but it's still a horizontal line, so our outer radius, the bigger radius, is going to be top curve minus bottom curve, so the line minus -3. So for part D, let's make sure we can see this. We get pi times the integral from -1 to 2 of the line, so 3x plus 3 minus -3, which is really just going to be plus 3 squared, minus, and then we're going to have the curve. The smaller radius is the curve, or the parabola, minus negative 3. So x plus 1 squared minus negative 3 or plus 3 squared. You can see that. All right. And so that one should give us 186.611. All right. And then our last one, it says we want to find the volume when our base is solid and the cross sections of, or they're building up cross sections that are right isosceles triangles. One leg is perpendicular to the x-axis. All right, so here's our formula sheet that I gave you the other day. Isosceles right triangle, where one leg is perpendicular to the x-axis. So this one right here. So side squared over 2, or 1/2 side squared, is our area formula. So for part E, our area formula is 1/2 side squared. That's part 1. Part 2, a side is going to be top minus bottom, or our line, which was 3x plus 3 minus our parabola x plus 1 squared. All right, so our volume formula is going to be the integral from negative 1 to 2 of our 1/2 of our side, 3x plus 3 minus x plus 1 squared, all that squared. This is our side squared dx. And that one gives us 4.050. So today we're just practicing using all of our formulas.